Okay, everything is buttoned up. All the screws are tight that I loosened up. I disturbed a natural gas connection right here, and I'd like to leak check it. So what I'm going to do is I'm going to take this gas valve, which is currently in on, and I want to turn it to off. So the way that you do that on this valve is there's a spring here. You have to bring that back and then turn this to off that way. Then I'm going to take this valve, turn that to on, which is in line with the pipe, that's on. Now this line here is pressurized. The joint that I disturbed is pressurized. Now I'm going to take my big blue, brush on blue, okay, which is a leak detector. I'm going to take that and I am going to put it around the two joints that I disturbed. What I'm looking for is I'm looking for bubbles. Okay? I am looking for bubbles to tell me that I have a leak. But everything actually looks pretty good. I don't see any bubbles. Not the bubbles I'm looking for. Everything's as long as I'm here, I might as well check this joint, even though I didn't disturb it, in case something malfunctioned here. This is all pressurized. Check that. You could even check this joint right here. Move my drill out of the way and just check that. It's not going to hurt you. You got your leak detector right there. There's another joint right there. Check that joint. Just checking everything, just in case there's something squirrely going on. But in this case, there's nothing, so we're fine. Okay, so I'm going to go ahead and close up the big blue, and let me shut this gas valve off for now. And I can turn this valve. Normally what I do is I leave this one to on, and then do my pilot lighting like this once I put the thermostat. Well, I don't even need the thermostat to light the pilot. I can light that now, and I keep a lighter right up here just for that purpose. So we are pretty good to go here. That's good. Let me button this up. All right, right now I want to see if I can get the thermocouple to light off. So what I did was I built this small little extension cord where the conductors are exposed, so I can put my amp probe on here real easily. So on the furnace electrical, I'm going to plug it in here so I can get my amp draw with the doors on with no issue. So I'm going to go ahead and plug this in. Okay, so we're plugged in here. I'm going to turn on the natural gas right here. Natural gas is now open. I'm going to take my lighter, see if it works. It does. And we're going to put it right there. Alright, it actually lit right off. So we're going to let that heat up the thermocouple for at least 30 seconds. And then we want to turn on the thermostat to heat and get these burners fired off. Now I want to start putting the doors on, so let me get the bottom door on and put that on right now. Top door is right there. It's not really going to make a difference if it's on or off the way this furnace is set up. It's okay to operate it without that door on. The way that the draft works, so this is just an 80% furnace, so there's no inducer draft fan motor. So basically your combustion air is going to go in here, and then your products of combustion are going to come out. Let me get the flashlight. Are going to come out these tubes right there, and then they're going to go up. I'll show you where they go up. They go up right there at the top, okay? So then that comes up to here, to this point, and then from here it goes into your B venting stack, and then up and then out of the residence at the roof level, okay? Outside the house. You don't need a draft hood like you do a hot water heater at this location, because the draft hood on this furnace is right here. So in case there's a pressure inside of the venting of the products of combustion, it will come down and roll out this way here to prevent the flame from being disturbed. So this is how the draft diverter works on this furnace, okay? So that's why you don't have like a hot water heater. You have a gap right there, but on this one you don't have the gap because the draft diverter is down at this location. So that's how the manufacturer did that, and that's very common for this 80% furnace. Alright, so I started filling this out with the unit number, the date, my name, what the furnace input is, what the furnace output is, the AC tonnage, which is 4 tons, and the rated external static pressure. And I put down NA because we don't know what it is because it's not labeled on the data nameplate. Now let me just show you a little bit about that. On the furnace right here, it should be an information about the rated external static pressure, but it doesn't have it because, let's see here. This just tells you from 70, this just tells you the heat rise from 70 to 100 degrees, a temperature of 0.1, 5 inches of water at that. Okay, that's the how much temperature rise we should get with a temperature with a 1.15 inch water column static pressure. I'm unclear if that's a supply static pressure or exactly what static pressure that is. Okay, so looking at my furnace chart, first reading that I want to get is this one right here, reading number 1, which is before the filter. I want to know what that is in inches of water column. So I know that my filter is in the back of the door right here. Shut this light off, put it at an angle. So I know that my filter is right under the door here because it goes, the air comes in and comes up. So what I did is I drilled a hole right there, and so it's on the other side of this plywood that this unit sits on. So that is going to be the same thing as a pre-filter reading right there because it's on the opposite side. So on the Magnehelic gauge, what I did is I took and just put a needle that you would use to blow up basketballs or footballs, and that is going to be my test probe. I don't have a pitot tube because I don't own one. So what I'm going to do is I'm going to put that down there. Hang on, I got too much slack here. Let me get this nice and flat. And I have to make sure, now remember, when you're looking at the Magnehelic gauge, there's 2 readings. There's the high and the low. So the high is on the top, the low is on the bottom. So what I'm going to do is I'm going to go to the low setting. So this one here you can see is the high, and then the one underneath that is right there. That's the low. Because this is my expectation, this is below atmospheric pressure, I want the low. So the low is going to be the bottom tap. So I'm going to take my needle and make sure that it's on the low. So actually I have 2 needles. Let me switch this around. Okay, here is my low pressure port. Make sure your hoses are not kinked at all. Then I'm going to take this, put it down into here, which is supposed to be getting the pressure that's down below pre-filter, okay? And then I'm going to see if this gauge reading moves. Now, watch the gauge. What I'm doing is I'm pulling it out, and then I'm going to put it back in, and then you'll see the gauge move as I put it back in. Very, very, very slightly. Pull it out, put it back in, See how the gauge just moves just a very, very small amount. I'm at the very bottom edge of the scale. So if you're looking at those lines, it goes 0.25 to the left of that, it's 0.20, 0.15, 0.10, so it's 0.05. So pre-filter is 0.05. So that is the number that we are going to populate for this point right there is 0.05 inches of water column. So 0.05. The next one that we want, okay, so 0.05 right there. Then you have a filter, then there's the next point right there. We need to know what that is. And we'd like to get the return air temperature, dry bulb, wet bulb, and the inches of water column. So let's start with the inches of water column. On the side of the furnace, over here, I drilled a hole earlier so I could put my reading into. Okay, there it is right there. I found it. I'm going to go in. Now there's the reading on the Magnehelic gauge after the filter, before the fan. That number is 0.125. 0.125. I'm going to pull it out and then put it back in just to show you the needle movement. If I can find that opening. There it is. 0.125. So let's go ahead and write that down. That number is this one right here. That is this number 2 reading, and that is 0.125. Now, as long as we're here, let's get our return air dry bulb and wet bulb. I got my thermometer here, vents are open on it, and let's go ahead and see what that is. Okay, so the dry bulb temperature is showing 82.7. Oh, come on. 82.7. 82.9. Okay, we'll call it 82.9. So we're going to put down here the dry bulb temperature is 82.9. Now let's get the wet bulb temperature. So by doing this, I have to hit the mode button right here and wait until that's the dew point right there. The dew point is 66. I don't want that. That's the wet bulb. That's what I want. So the wet bulb, 71.6. We'll call it 71.5. Oh wait, is it still dropping? 71.4. Hold on. Hold away slightly. Okay, we're still on wet bulb. I'm going to call it 70 point. It's bouncing around, but let's just call it 70 point. Hold on. It's bouncing around good. Alright. I don't want to wait here forever because I'm impatient and I want to get moving. I'm going to call it 72.1. That's it. Okay. So that is 72.1. That goes right here. 72.1. That's the dry bulb. Now, if we want to know the air filter pressure drop, we're going to take 0.125 and subtract it by number 1, 0.05. That is going to give you your air filter pressure drop. So let's go ahead and figure that out. So if I take my phone and go to calculator mode, clear that out, type in number, actually it should be 2 minus 1. That actually should be 2 minus 1. 0.125 subtract number 1, 0.05, 0.05 equals 0.075. So that is 0.075. Now, that's pretty good. That's not a bad pressure drop across the filter. Mind you, I just cleaned it. Let's do another test. What I want to do now is I want to take and use the low and the high right across the furnace. So what I'm going to do is take the low, which is right here, I'm going to stick that in before the filter, and I'm going to take the high and I'm going to put that in after the filter and see if that reading equals this reading right here. That's what I'm going to do right now. I have another needle valve right here, so let me get that out of the package and give me a second to put that in. Okay, I got it hooked up so that the high probe is actually here, or here on the system. That's the high probe, and the low probe is here. The reason why that's a low probe, it's the lowest pressure on the system. It's just before the fan. Now, when I do that, this is what the reading is. It looks like it's 0.08. My mathematical reading on here is 0.075, pretty much the exact same number, okay? So this is it, just doing the math by taking each point individually, point 1, point 2, taking those points one at a time, and then just doing the math on the calculator. And then here is the actual reading, just plugging the low and high ports directly in, doing it that way, confirming that information. Let's continue on with our analyses. Now, we want to now get after the coil, the heat exchanger, and before the coil, okay? That's going to be point number 3. I want to know what that is in inches of water column. Now that is going to be a high pressure, not a low pressure. So what I'm going to do is I'm going to take out the 2 probes out of here. I'm going to take the high pressure probe, which is the top one here, and I want to put it between these 2 points. Now, on my unit here, what I did was I drilled a hole right there. Now, before I drilled that hole, I went through, first of all, I looked at the unit. If you look at the way the unit is constructed, you can see the liquid line is here. Let me get a flashlight. You can see this a little bit better. Okay. Now, this is the liquid line. My finger is touching the liquid line. This is liquid refrigerant coming in. It's supposed to be going to an expansion valve, some type of metering device inside of this unit. Actually, I don't think it's an expansion valve. I think it's a fixed metering device. That's my assumption. This here, where the insulated line is, that's the suction line where the vapor refrigerant is traveling back up. So here the refrigerant's coming down, here it's going up. The way that this coil, because of this construction, this is a horizontal coil. This is the condensate drain line that should be connected to a drain pan at the bottom. You do not want to drill into this drain pan. That is going to cause you leaking water. So you can't willy-nilly just drill holes in this thing wherever you want. You could hit the drain pan, you could hit the coil, you could hit something you did not want to hit. So what I did was I took these 2 screws out and bent this back. I left this hood in place, and and then felt with my finger, and I could tell that the drain pan started right here. So by me drilling here, I was below the drain pan, but in the airstream. So I was safe to make that drill hole right there. So that is what I'm going to use for my reading right now. So let's get the magnehelic gauge up here, make sure it's nice and flat, use the high side reading. The low side reading is just going to atmosphere, it's not going to go to anything, so I'm not going to plug that into anything, and I'm just going to plug in this high side reading right there, and you can see it come up right there on the magnehelic gauge. Now let's write that number down. That number is 0.35. 0.35 between these 2 points. There it is, pulling it out, and put it back in, do one more test. Double check. 0.35. Good. It's a little bit less. It's actually about 0.34. Well, 0.35. It's good enough. Okay, so that number 0.35 goes right here. 0.35. That's that number right there. Now we need another number. This number right here after the coil where it goes into the plenum. Now, here's the coil. This dot here is, this sample point here is before the coil. Now, I took out a screw right there, and that is where we're going to go after the coil, and it goes into the plenum. Okay? Could be anywhere up there, but since there was a screw right there, it was just easy for me to remove that screw and use that as my sampling point. This is going to be a high pressure, so I'm going to take the high pressure side of my meter, my magnehelic gauge. I'm going to put that in right there, and as I put that in, that is going to give me a number. That number is 0.15. Pull it out, goes back to 0. So that's 0.15. So let's write that down. 0.15 is this right here. 0.15. Now, we can determine the coil pressure drop by taking 0.3 and subtracting 0.4 from it. So let's go ahead and do that. So we'll do that just like we did the other one. What we're going to do is we're going to take point number 3, 0.35. We're going to subtract point number 4, which is 0.15. That's going to equal 0.2. So we know that the coil pressure drop is 0.2 inches of water column, okay? So that's not a bad pressure drop across the coil. The coil is not like plugged, where it's producing a plug of airflow. Now, we want to know what the amps are on the, right now we're in heating mode. Let's go with supply fan amps. Let's figure out what that is right there. So my meter shut off, but let's put it back on. Go amperage AC. There's my backlight right there. And right now the fan is drawing 3.83 amps. Okay, it's 3.83. So let's write that down. And that goes heating supply fan amps 3.83. Okay, now that we know that, we can figure out a few more things. Now we do want to know the total external static pressure. That's going to be 2 plus 3. So 2 is 0.125 plus 3, which is 0.35. Okay, let's go ahead and get that going. 0.125 plus 0.35, 0.35 equals 0.475. So 0.475. Now my unit did not have a rated external static pressure, but if you're at a ½ inch or less, which is what I am, that is considered good. I don't have a restricted airflow from a total external static pressure point of view, which is how you want to review this. Now, I want to do another check. What I want to do is I want to check external to the heat exchanger. So what I want to do is I want to put in a sample point low here and high here, and I want to see what that comes out at to see if it equals 0.475. So that's what I'm going to do right now. Okay, I got the low port, which is the low port is the one there on the bottom, coming down, and I plug that into the side of the unit, which is after the filter. Okay, and then on the high side of the magnehelic gauge, which is the top line, I got that coming down, and that is plugged into right there, which is on the upstream side of the AC coil. There is your external static pressure on the magnehelic gauge. That is at 0.5 inches. That's a half of an inch of static pressure, water column. That is a good static pressure. This unit is breathing, and it is allowing the proper amount of airflow with the fan in heating for CFM. Okay, now that I know that the unit is breathing appropriately, the AC unit has good airflow in heating mode. My expectation is to be the same thing in cooling mode, same thing with the airflow, but we'll verify that once we get to cooling. Now what I want to do is I want to put the thermostat, I want to put my jumper that I put in there where I jumped out those 2 leads on the fan thermostat. I want to put those back to normal. I want to light this pilot off, get this thing on in heating mode, give it about 3 minutes, and then I want to get some more measurements to see what that temperature rise is and log all that down. Plus we'll be able to check the flame and see how that's going. So that's what we're going to do. Okay, so I disconnected the power, I unplugged the unit. Now what I want to do is I want to pull out my jumper. I got to figure out which one I want to pull out, the bottom one or the top one. See if I can show you with the light. Put this here, like this. It doesn't matter which one I unplug here, because this is just a switch. So that is good. Thermostat is set at about 95 degrees Fahrenheit. Thermostat is set, I'm fine there. We're totally good. I'm ready to light the burner off. So let me get my my flame going here. Okay, we've got the flame. Alright, the pilot is relit again. We're going to let that stay on. I don't need this door anymore. I can put that door back on. I can plug this back in because we're going to be using the thermostat now to put this unit on. Alright, here's the thermostat. Set clock. It lost its memory because I unplugged it upstairs. Let's not worry about that. Oh, it's going to make me do that right now. Wait a second. See if I can bypass that. Alright, I'm going to go to System. I'm going to go to Heating. It's currently set at 82. So I have to go higher than 82. Let's see how high the system will let me go. Come on. 90. It'll let me go up to 90. Alright, so right now the heat is on and the unit should absolutely light off. So let's go see it light off. Okay, this is the first time that we fired off since I did my cleaning of everything. So I want to observe the flames. Boy, the flames are lazy, lazy, lazy. That is the laziest flame I've ever... That looks lazier than normal. The coloring. So I'm looking at the flame, I'm looking at the coloring, trying to determine how everything is going. Now what's happening is the heat exchanger is heating up and I'm waiting for the fan to... The fan switch is going to turn the fan on when it reaches 95 degrees. When that happens, I want to observe the flame to see if any of these burner tubes are showing a leak that would distort the flame compared to what you're seeing now. So you want to compare now to what you would see once the fan kicks on. So we have to give it a couple minutes. It's going to take a few minutes for the fan to come on. Mind you, this is a 40-year-old furnace. Maybe that's just what the burners look like on a 40-year-old furnace. And the newer furnaces, they look a lot nicer. You can see some coloring going on right there. Oh, here we go. The fan is kicking on. We can check the amp draw on the fan, which we did earlier. I think it was 3.83 earlier. So it's 3.8 amps, which is fine. So we're fine on the amps. Now we're looking at the heat exchangers to see if there's any different flame going on. And I don't see a different flame going on. Now what we're going to need to do is we want to get this, we want to let a few minutes go by. We want to see what that supply temperature is going to turn into and what it settles out at. I still got the Helix plugged in. And it's still showing external static pressure of 0.5. That's not going to harm anything. It's actually getting hot right there. That's actually very hot. But that's just the way it is. I got to make sure that my equipment doesn't get too hot up here. Okay, I got my field piece and I've got my thermocouple plugged in here. So what I'm going to do is I'm going to put it to the correct setting and I'm going to plug this in to see if I can get a reading up here. And the reading is, oops, hold on. Got it at about 130 before it popped out. Let's see what it is again. Alright. I'm getting 147, 148, 149. I'm trying to see if that's going to settle out right there. Let's see what that number is. So you can see that. And 146, and it looks like it's settling out at 146, 147. I'm going to call it 147. Okay, so now that I know it's 147, I want to fill that out on my sheet right now. Let me see if there's any other information I need at the same time, but let's get that number. Alright, that temperature for the supply air heating temperature was 147. Alright, so we're going to leave that. And I got the amps there. I actually have all my information for the heating. I want to go shut the thermostat off because the house is already super hot. So let me go shut the thermostat off and let that shut off. Okay, we're back at the thermostat and let's lower this setting to a normal heat setting. It'll be something like 72. And I'm going to go to system off for now. Okay, with the thermostat off, the flame has shut off, but the burner is going to stay on, and it is going to stay on until the heat exchanger reaches the set point of 95 degrees Fahrenheit. At that point in time, it's going to shut off. Because this is still summer, I don't need the pilot, so I'm going to go ahead and shut the pilot off. So I'm going to shut this valve off there, and you'll see the pilot shut off. There's the pilot flame, and the pilot flame just shut off. We don't need the pilot because it's the summer. I'm just doing this as testing, okay? Now let's figure out the heating CFM. So what is the delta T? The delta T is 3 minus 2. So 3 is actually, okay, it's the same. I'm going to put down 3 is the same as this one, 147. So 147 minus 2, that is going to be dry bulb, not wet bulb. So 2 on the dry bulb. So we'll say 3 minus 2 dry bulb is going to be, let's see here, 147 subtract, we're going to take the return air temperature dry bulb 82.9, 82.9, that equals 64.1. So that delta T is 64.1. Now we know that the delta T is 64.1. We're going to multiply that by 1.08. So we're going to multiply that by 1.08. That is going to equal 69.22. 69.22. We need the BTU output. We know that's 80,000. We want to divide that number by 69.22. So we're going to take 80,000 and we're going to divide that number by 69.22. 69.22 equals 1155. 1155 CFM. Okay, 1155 CFM. So now we know what the heating CFM is. We'll compare that up against the cooling CFM and see what that is once we get into the cooling. Okay, the furnace is shut off. We're at 95 degrees Fahrenheit on the thermometer right there, so the fan has shut off. You can see the magnehelic gauge is turned to 0 because the supply fan is shut off. Okay, that concludes the video. So you saw the checklists. I had 2 checklists. This one here was pretty much for the AC, and the other checklist, which is this one here, is pretty much for the furnace. You saw me fill out both of them in great detail. If you want these checklists, you can request them on my website. There's a link down at the bottom for you to do so. I hope that this video was informative. It was not necessary for me to put gauges on this unit, judging by the temperatures alone. I only put the gauges on the system because I just wanted to go through and fill out the checklist 100%, create a baseline. I've been living here for almost 10 years. I never even put gauges on this system. Why? Because it wasn't broken. I just felt like if it ain't broke, don't fix it. And for the cooling, the refrigeration cycle was working fine. Of course, I've been washing my filter every so often. In my case, we run the thing so little, I only need to wash the air filter twice a year. Once for the heating system and heating season, and once for the cooling season. That's it. But anyways, you saw my delta T's. I've got greater than 20 degree splits across the evap and the condenser coil air temperatures. If you're seeing things like that and your air filter is clean and you're getting good airflow and you're not restricted, your system's probably just fine. You don't need to do anything to it. But anyways, I just wanted to go through all the different steps that you can check. As a DIYer, I can check my capacitors, I can do stuff like this and just see how everything is operating. I hope you found this video informative. Please click on like, give me an extra like, subscribe to my channel, Ken Training. Check out my other videos, I've got plenty of them. I will see you later.